Hey guys, welcome back. This is part 2 of my full solution to a facility location problem in Python. So we're just going to keep going with that. We were talking about setting the constraints. So in our problem, this is our first constraint. So these are my questions that I had in my PuLP basics videos that are really important when you're setting the constraints. So the first thing you want to ask yourself is there a for all sign? In this case there is. It says for all I, we are going to sum over the amount serviced from I to j, and we want that to equal the demand for all customers. So when there is a for all sign, we need to first start off with a loop and say for I in customers. Again, I was our index for customers as it is up here, so we want to keep that consistent. And then we want to start adding all that to our problem variable. So the first thing we look at is there a summation? What are we summing? So there is a summation, so we say LP sum. And then we need to look at the next part, which is our decision variable. We called that serve underscore vars the amount serviced from I to j. And then in this case, we are not indexing it the exact same way as we would up here with the dictionary. We need to instead say bracket I comma j, parentheses, bracket. But then we still need to have our other loop in here for the summation. We're saying we're summing over the j. So we need to say for j in facility. The next thing we want to do is we want to look at our sign for our constraint, and it's an equal sign, so we do two equal signs. And then the next thing is our demand dictionary. So look up here, we can see that demand is what we call this variable or this parameter. And then the subscript is I, and we don't need a loop because we're not summing that over. We're just making sure it's equal to that. And we already have that for all over right here in this loop. So that's our first constraint. I'm just going to say constraint 1. And then let's move on to the next one. So is there a for all sign? Yes, we're saying for j in facility. And what this constraint is, it's saying for all facilities, we want to make sure that the amount serviced from I to j, summing over all the I, is less than or equal to the max amount that facility that is chosen, whether or not, depending on whether it's chosen, that it's less than or equal to the max amount that it can produce in that year. So we did our for all, then we need to assign this to our problem variable. We need to say there's a summation, so we need to say LP sum. And then the next thing is our, again, our serve underscore vars decision variable. And then we need to index it like this, I comma j, bracket, and we're still on this side of the constraint sign, and we still haven't put in what we're summing over, so we need to say for I in customers. And we look at our sign, and it's a less than or equal to, and then the next thing is our, it's M subscript J, and we name that max amount. And then we need to index that with a J and multiply that by our decision variable Y, which was use underscore vars index J. And that, again, doesn't need a loop. We're not summing anything over on this side. Going on to the next and final constraint, we are actually summing for all I and for all j. So we just want to start with for I in customers, colon, and then for j in customers, or j in facility. And now we are going to write our constraint. There is no summation sign, so we just need to say our decision variable x serve underscore vars bracket I comma j, and we need to make sure that is less than or equal to our demand bracket I times our y variable, decision variable, which is use underscore vars bracket j. So I guess this constraint is making sure that the amount serviced is less than or equal to the demand times whether or not that location was chosen. And then since we have all our constraints, now we can go on and we can solve our problem using Python. So let's say solution. We're going to use our prob.solve function. We also want to print the status, make sure it's optimal. So I'm going to say status colon comma, and then we need to say LP status bracket prob dot status bracket parentheses. And then the next thing, we want to print which facilities were chosen. So in other words, we want to print our binary variable, that was this one. So in order to do that, let's set, actually I'm not going to set, did I set a tolerance in this one? Let's go ahead and set a tolerance. So this is just in case something goes wrong, 0.00001, and we're going to say for I in facility, because we are printing our facility decision variable, so we want to say if use underscore vars I dot var value is greater than the tolerance, then what's going to happen is we are going to print establish facility at site comma I. So what this is doing, it's saying for all the sets, or for all the elements in the set of facility, if the value that the solver chose is greater than 0, or in other words, if it equals 1, since it's binary, then that means the facility needs to be established at that site, and that's going to be printed using this line. And then next, we also want to know how much is needed to be serviced from customer I to location J. So we're going to say for that, for v in prob.variables. And I have noticed that this line is also going to print this again, but I don't think that really matters. I just like to have this so that you can choose what you want to type, what you want to write out, so it looks nice and it says established facility at site, blah, blah, blah. Whereas you'll see that when this prints, it's kind of unclear what we want to happen. It just gives the value for that facility as 1, but someone else looking at that might not necessarily know what that means. So it's good to have that printed, that we want to establish a facility at that site. So then the next thing we need to do is say print v.name, comma, equals v.var value. And that's going to give us the variable and then the value for that variable. And then the last thing we want to do is we want to print our optimal solution. So we want to say print the cost of production in dollars for this for 1 year. I think that's what the problem had. Let's see. Cost of production. Cost of production is going to be, comma, value prob dot objective. And this value prob dot objective is going to give us that optimal value. So let's see if this runs. Hopefully all the syntax is correct. And I forgot a colon, of course. And does that need a colon? Let's see. And then we also need a colon right here. Let's try that again. I guess we need an indent here as well. Alright, here we go. So it told us from this loop that we have right here, we want to establish a facility at site 2 and 3, and then it gives us the amount serviced from customer 1 to facility 1 is 0, and it does that for all customers and all facilities. So this first one is our customer, and then the second part of this is the facility, and it tells us how much to service, which is cool. And then it prints that, but I just think it looks nicer when you use your own loop. I'm sure there's probably a way to do that for these as well. And then it also prints our optimal solution. So this is our cost for 1 year. And then up here, I forgot to mention, it says that this is our optimal solution. So hopefully you guys know how to solve a facility location problem using Python now and the PuLP package, and hopefully you can see that PuLP is really great for linear programming, and in general Python is just great because it's really easy to go in and change all your constraints and customize them however you want. And so hopefully you guys were able to learn how to find the optimal solution using Python.